Yes, good morning to you all. So today I welcome you all to this particular session. So today we are going to see a new topic in sixth unit, that is last unit. So in syllabus point of view, it is fourth unit, but we are discussing as last unit uh, in this EMI subject. So today we are going to see oscilloscope probes. Oscilloscope probes. So far we discussed the basics of CRO. So how the CRO works. So what is the basic principle involved in CRO, and how the input is connected, and how that input is processed through different parts or different parts of the circuitry, and finally how that is going to display on the screen. So the basic CRO and the basic elements of CRO, that is CRT, and inside the CRT we have the deflection systems like vertical deflection plates, horizontal deflection plates, and finally the beam of electron is going to strike the screen where we can see the bright spot. Continuously the beam of electrons is striking the screen, thereby at the end of this we'll get a solid wave on the screen of CRT. So this is the basic construction and basic working of CRO. So now when we want to connect the CRO with your circuitry, so generally the CRO is output device. So we are going to monitor the output signal of your circuit, so on the CRO screen. See, now this is a very important topic as a learning engineers. So this is very important topic, how this electronic circuit is going to interconnect with the CRO, and how you see your circuit output on the screen of CRO. So this is the basic and very important application of CRO. Probes, without probes, we cannot connect the circuit output with your CRO. See here on the screen also I have shown one circuit here, one circuit. So this is the circuit. Just I have taken one example circuit. This circuit output, the circuit output is connected with this part of probe. So this is the first one is electronic circuit, the second one is probe, third one is CRO. Now as we are studying the third year BTech, so we know how to construct the electronic circuit. Already we might have studied in our previous semesters, and we have already done a lot of experiments, number of experiments on how to construct the electronic circuit on breadboard and some PCBs also. So rectifier circuit, oscillator circuits, amplifier circuits, schematic trigger circuits, or any other applications. So we are taking the different components and we are we are just putting on breadboard, so in a proper organized structure. And this proper organized structure gives one output, that is one particular output, one particular useful output. So that output we need to display on the CRO screen. What is the use of displaying this signal on the CRO screen? So to measure the properties of the output. So that is, one is amplitude, and the second one is frequency, third one is phase relationship with the input and output signal of the circuitry. So to measure the properties of this circuit output signal, so we need to display that signal on the CRO screen. So that is the purpose of CRO. So now how to connect the circuit output with your CRO? Now we have three different devices here. So first one is electronic circuit, second one is probe, third one is CRO. Now we have the three available, all three devices. Now how to connect? Now see, to connect the circuit output with CRO, we need probe. We need probe. So now the present topic is CRO probes, or we can say oscilloscope probe. So this oscilloscope probe helps us to connect your circuit output with your CRO, to connect circuit output with CRO, so that the circuit output is processed, or it is carrying by this oscilloscope probe and connected to the CRO. So then we'll see a signal on CRO screen. Once the CRO screen indicates the signal, so then we can measure the amplitude of the signal, as I discussed just now. So we can measure amplitude of the signal, then frequency of the signal, phase relationship between input and output signals of the circuit. So 3 points. Now the current topic is how to connect the circuit output with your CRO. So to connect these two, we need the help of oscilloscope probe. And when we are choosing oscilloscope probe, it must have some specifications. It must have some features. What are those features, and what are the essential conditions? Essential condition to use any connector as a CRO probe. It should have some specifications, some significances. It should have its own characteristics, right? So characteristics means it should not alter the actual output of circuitry while it is carrying to the CRO. Yes. So one end of this probe is connected to the circuit output, and second end of this probe is connected to your CRO. See here, this is CRO end. So if you see this probe, so this is CRO end. So now this we can call it as BNC cable or banana cable, and the second one is, this is connected to the circuit side. So circuit side, CRO side. So now the circuit output is carrying by this electronic cable, or you can say it is a oscilloscope probe, and then it is connected to the CRO. Now it is acting as a medium between your circuit and CRO device. So this carries your original signal and gives to the CRO. So then your CRO is simply understand as signal is coming input, then the entire components or blocks gets activated and they function, and finally the output signal is displayed on the screen. Yes, displayed on the screen. Once the signal is displayed, then we know that how to measure it, how to measure the amplitude, frequency and all. So now in this chapter or in this class, so we are going to see what is probe and what is its specifications, and what are the types of probes, and what are the specifications of each probe, so that we are going to see in this particular session, right? So coming to the basics, CRO probes. So oscilloscope probe are a conducting wire. It is a conducting wire, so which is used to establish a connection between the circuit under test and measuring instrument, that is CRO. So while connecting the test circuit, the probe does not alter. This is very, very important here. This is a very, very important condition. The probe does not alter the actual output of your circuit while it is carrying your circuit output to the device. It should not alter, it should not change the actual output of circuit. The meaning is that whatever the output will have at the circuit, the same thing should be transmitted or carrying to the CRO. So in between this, it should not add any noise, or it should not attenuate the signal, and it should not amplify the signal. Yes. So this should not change the signal, right? In one word, we can say it should transmit the original signal as it is without adding any noise or any attenuation, right? So that is one condition when we are using a CRO probe. So once again, I am repeating this because it's very important. While connecting the test circuit, the probe does not alter, load, or disturb the circuit and signal conditioning to be analyzed. Yes. So any signal going to the oscilloscope first pass through the probe. First point is, the first component is probe. First circuit output is connected to the probe. Then the second end of the probe is connected with the CRO. And here the bandwidth, one more specification is coming into the picture, that is bandwidth. So whenever the probe is the first element, then therefore the bandwidth of the probe combines with the bandwidth of the CRO. So first we are connecting the one end of your probe with the circuit output, then it is carrying the signal. Then the bandwidth of your probe and CRO getting combined. So the probe bandwidth must be higher than oscilloscope bandwidth. The probe bandwidth must be higher than oscilloscope bandwidth, and nearly the bandwidth of probe is chosen at least 10 times of CRO frequency. 10 times of CRO frequency. And the probe should have high input impedance. So to avoid loading effect problems, and to avoid the alternative, to avoid the alter in the actual circuit output, so it should have high input impedance, right? So these are the first basic things. So first, it is a CRO probe is a conducting wire. Second one is, whenever you are using a CRO probe, it should not alter the circuit output, and then the bandwidth of probe is combined with the CRO probe. That's why the high bandwidth of probes is chosen. And to avoid the loading effects, so high input impedance probes are highly preferable. Then the ideal oscilloscope probes offer the key attributes. So first one is ease connection, absolute signal fidelity, zero signal source, and complete noise immunity. So this is having these four attributes or features. So ease of connections, absolute signal fidelity, and zero signal source loading effect, zero loading effect, a complete noise immunity. It should not have any noise, right? Even some noise is present, that should have some overcome features inside its construction. So general diagram of this probe, general structure of probe is given here. So this is the general structure. So probe tip, probe, second element is probe head, third one is cable, and fourth one is termination end, that is connected to CRO. So this is connected to the circuit. So this is circuit, it is connected to circuit here, and the second end is connected to CRO. It is connected to CRO. So in between this, so this probe is having the probe head coaxial cable. So now we'll see what is probe head and coaxial. Probe head, probe tip. So probe tip is the sensing element. So this we can also call it is a sensing element. So it senses the circuit output. This we can call it as sensing. Sensing means it senses the signal. It understands the signal. it senses the signal and probe head, and then it transmits the cable, and finally it is connected to CR. So the explanation of each point I have given in this slide. The probe tip is the signal sensing circuit, right, for your understanding purpose and easiness. So I have given each point in detail here. The probe tip, that is element first element in CRO probe. This is this probe probe tip. The probe tip is the signal sensing circuit. Sorry, excuse me. Signal sensing circuit. It may be passive or active. So there are maybe option as a passive or active. So if it is a passive means, so it uses the passive components. Suppose a sensing element is designed with the passive components, then you can say the probe is passive probe. And the second one, if it is active probe, it consists of active components like FET source and voltage follower circuit. FET source, voltage follower circuit. So there may be two types of basic CRO probes, passive probes and active probes. So these passive probes and active probes is classified based on their probe tip elements. So passive means this may be a resistor, capacitor. It consists of resistors, capacitor. And active means like it may be having BJT or bipolar junction transistor, field effect transistor, like voltage follower circuits. Next, the probe cable is a special coaxial cable. Probe cable is a special coaxial cable. Special coaxial cable with quite, see here, these properties, with quite effective shielding. Yes, shielding means to avoid the interferences, surrounding interferences. So there are a lot of interferences may be there. So to avoid these interferences, this entire cable is shielded. So to carry the signal as it is without adding any noise or amplifying signal, attenuating signal before connecting to the CRO. So that's why it needs to be shielding, right? Next, its capacitance is greater than the open wire, right? The probe capacitance is greater than the open wires. So if you consider the capacitance of this probe, so it is greater than the open wire, and in some cases it is satisfactory conditions. Now we have seen some basic requirements of probes, So now we are going to see the types of probes. So there are different types of probes available in the market. So there are different manufacturers, different vendors, right? They are developing different types of probes to connect the circuit output with your CRO. So in that, the most important and most commonly used probes I have given as per your syllabus here. Some of them are there in your syllabus and some are not there in your syllabus, but for your information purpose, I am providing here. Yes. First one is direct probe. Second one is isolation probe. Third type of probe is high impedance or 10:1 ratio probe. So active probes, right? Current probe, differential probes. So these are the different types of probes available in the market. So now we'll see one by one in detail. So in the beginning of this class, I have given the basic structure, circuit, then probe, and output device is CRO. These three combinedly gives a full-fledged application. The circuit output is carrying out by the probe, and then it is displayed on the screen of CRO. So now circuit. So we know the circuit. We already studied circuit, and we know everything about the CRO. And now we are focusing on how to interconnect these two. So while interconnecting these two, uh, we should take care about the probe should not alter the circuit conditions, or probe should not load on the circuit condition, or probe should not change the actual output of circuit. So these are the basic things while we have to, while connecting the circuit output with this thing. So this we have to remember it, right? So first one, direct probe. Direct probe. So in this we'll see what are the features of direct probe and what it means. So while you are using this direct probe, what is happening in the circuit? So that each and every point we will discuss here, the point by point. So please listen carefully. See, these are simplest type of probes. So basic probes, basic types of probes, simplest probes. These probes terminate with banana tips or uh, other types of tips. So this gives the construction. So this is a terminating probe. The tip of the probe has crocodile clips or other means of connecting the oscilloscope to the test circuit. So this is crocodile. So this is connected to uh, circuit. This is connected to circuit, and this is connected to CRO. So this is a banana clip, banana. This is a crocodile clip. So the probes use shield coaxial cable. As I said just now, the shielding is very important to overcome the interferences in the chip. So this type of probe does not provide any improvement in the input impedance. Input impedance, there is no change or improvement in input impedance. So input impedance is the main important parameter or characteristics to avoid the loading effect. But in this simplest type of probe, that is direct probe 1:1 or 1:1, so it will not have any improvement in input impedance, right? What is the impedance is there at the basic probe, so that is remains constant, and it will not improve any loading, or it will not reduce any loading effects. Then input impedance of vertical amplifier or general purpose CRO is 1 mega ohm, so CRO, and capacitance is 30 picofarads. So when this direct probe is connected, the input resistance remains constant of 1 mega ohm. So that is what just I said in the previous slide, last point. This type of probe does not provide any improvement in the input impedance, right? So the continuation to this, when the direct probe is used, the input resistance remains constant. The CRO input impedance remains constant. That is 1 mega ohm. That remains as it is 1 mega ohm. There is no change in the. But one thing is, some capacitance is added with the CRO capacitance. The actual capacitance of CRO is 30 picofarads, but here due to this direct probe, some capacitance is increased. But this should not expect. In the real time environment. So that's why to minimize this capacitance, one more resistor is added in series with the test leads. So that is called carbon resistance. Carbon resistance is connected in series with the test leads. So such probes are generally called isolation probes. The meaning is, the first direct probe is a very simple one, and we can connect your circuit output with the CRO, and it is not having any improvement in the input impedance, but there is a change in the capacitance. Some capacitance is added with the CRO capacitance, right? So actual capacitance is 30 picofarads, but due to use of this direct probe, the capacitance of CRO will some added. So but it should not expect in the real time environment. If you leave as it is, then what happens? Some error may be indicated in your original signal. So that's why this capacitance should be maintained the same value. So to overcome this increment in the capacitance, one carbon resistor is connected in series with the test leads, input side. So this type of probes are called isolation probes. So the meaning is, the one of the disadvantage of direct probe is increment in capacitance of CRO. So that is overcome. That is overcome in the isolation probe. So next we will see isolation probe. Second one is isolation probe. See, isolation probe. Just now I said that one carbon resistor is connected in series with the lead. See, this is input side that is connected to the CRO. So here this is a carbon series resistor. Why this resistor is called? To compensate the increment in the capacitance of CRO. Because direct probe increases the capacitance. To reduce that capacitance, a series resistor is connected here. Then shielded core and second end is connected to the CRO. So coming to the specifications of the CRO, the input capacitance of oscilloscope and stray capacitance of test lead are very high. Yes. So this basic thing. So as we discussed now, so the input capacitance of oscilloscope and stray capacitance of test lead are very high. It causes the sensitive circuit to break into oscillation when CRO is connected. The meaning is, if you use the high capacitance probe, that is direct probe as it is, then what happens? The signal displayed on the screen of CRO is oscillatory one. So continuously it oscillates the response. Okay. Continuously it oscillates the response. So this is one of the drawback. So to overcome this, a carbon series resistor is connected. This effect can be prevented by isolation probe. The isolation probe is made by replacing carbon resistor in series with the test lead. The disadvantage of previous case, that is direct probe, is overcome in the isolation probe. So an isolation probe is employed to avoid the undesirable loading effects also. Undesirable loading effect of shield probe. So this probe causes slight change in amplitude. You see here. So use of direct probe will not have any change in the resistance and having only change in capacitance of CRO. But use of this probe causes slight change in amplitude of waveform and a slight change in the wave shape. See, this is also just like one, we can say that it's a drawback or limitation, not drawback, we can say limitation. So use of this probe slightly increases the amplitude of the original output of circuitry and slightly changes the wave shape. So to avoid this possibility, a high impedance compensated probe called low capacitance probe, that is 10:1 probe, is used. That is the next type of probe. Now coming to the second probe, that is isolation probe. It overcomes the disadvantage or limitation of earlier probe, that is direct probe, and this maintains almost the same thing, the resistance and capacitance of circuit as it is, CRO capacitance and resistance also as it is. But with this, the one more new problem is arising here. So what is that new problem? It changes the amplitude and waveform of the shape of waveform of the circuit output. This is one new problem using this. So it avoids or it minimizes the previous problem, and again it introduces new problem. It is a chain process in development, right? So, The second, it is a new problem, that is change in amplitude. This is also not expected in while connecting the circuit output with the CRO. So it should not change any amplitude or waveform. So to overcome this disadvantage or limitation of this isolation probe, so we are going to see the third one. So that is 10:1 isolate 10:1 probe. So that is called high impedance probe. Third one is high impedance or 10:1 probe. 10:1 probe. So I will stop with this high impedance probe because time limitation. So just we will see this high impedance probe. So in the next class. So now what we discussed in this class. So first one is the structure and the position where we use the CRO probe. CRO probe is used between the circuit output and CRO inputs. And the basic essential or basic requirements of uh, CRO probes. It should not alter the circuit conditions, and it should be a conducting one, right? And this should have a high input impedance to avoid the loading effects in the circuit. And the basic structure of CRO probe also, we have general structure. And the basic attributes, the ease of connection, it should have noise immunity, right? So these points also we covered in this class. And the types of probes, we covered the two types. First one is direct probe and second one is isolation probe. Direct probe is a very simple probe and it is having one limitation, that is it increases the capacitance of CRO. There is no change in the resistance. So to overcome the increment in capacitance, so we are going to see we are going to use the second type of probe. So that is isolation probe. So isolation probe overcomes the capacitance increment in the direct probe, and at the same time it increases the amplitude and slightly changes the shape of the signal, right? So that's why to overcome this disadvantage and to carry out the same features of isolation probe, so third one we are going for high impedance probe or 10:1 probe. So this probe will continue in the next class. There are some more probes, so we'll continue in the next coming classes, 2 to 3 classes. So high impedance probe, and next one is current probe, differential probe. So that will continue in the next class. Thank you.